Now we've learned about solubility a little bit already. Remember that if a salt is soluble, it means that it will dissolve in water. If a salt is insoluble, it means that it will not dissolve in water. We've studied phase notation a little bit, but remember, if a salt is soluble in water, we write the phase notation AQ. That means aqueous or dissolved in water. If a salt is insoluble in water, write the phase notation S. Remember that S means solid. So if you place an insoluble salt in water, that salt will simply stay or remain as a solid at the bottom of the beaker. Now we do have some guidelines to help us predict if a salt will be soluble or not. So we're going to use those guidelines to predict if the following salts are soluble or insoluble. Let's first predict if sodium sulfate will dissolve in water. Now on the back of your periodic table, you'll find these solubility guidelines. Here's how these work. This looks like there's a lot going on here, but with some careful study, you'll begin to understand these guidelines fairly quickly. So these are soluble compounds. Soluble compounds usually contain lithium, sodium, potassium, or ammonium. And there aren't any exceptions. So that means all sodium compounds, all potassium compounds, they're all soluble. Also, if we have nitrates, chlorates, perchlorates, or acetates, those are also soluble all the time. There's no exceptions. Chlorides, bromides, iodides, those are usually soluble too. However, there are a few exceptions. For example, if you see silver chloride, well, that is not soluble. Or lead 2 iodide, that's not soluble either. Most fluorides are soluble, but here's a few exceptions. Additionally, sulfates are usually soluble too, with the exception of these sulfates. So for example, calcium sulfate, strontium sulfate, those would not be soluble. All of the other sulfates would be soluble. Here's a list of insoluble compounds. Carbonate, phosphate, and these here, all of these are insoluble compounds. And you won't really find any exceptions to those other than lithium, sodium, potassium, ammonium. And remember that these four are always soluble. There are no exceptions. Also, hydroxides are usually insoluble too. If you come across barium hydroxide, well, that's slightly soluble. So if you have barium hydroxide and you try to dissolve it in water, some of it will dissolve in water, but parts of it will not. So I know that we went over these solubility guidelines fairly quickly, but let's practice a little, and then I think it will make more sense. So sodium sulfate. We can either look up sodium or we can look up sulfate. You can look up the cation or the anion. Either way will work. Let's look up sodium under soluble compounds. And you can see we have sodium listed as a soluble compound. And there are no exceptions. So sodium sulfate would certainly be soluble in water. So we write AQ for the phase notation. What about potassium carbonate? Well, if we looked up potassium, we would see that potassiums are always soluble with no exceptions. But let's say you looked up carbonate. Let's find carbonate. Well, you see carbonate listed as an insoluble compound. But then if you look carefully, you see that one of the exceptions would be potassium carbonate. So potassium carbonate is soluble in water. Let's try one more. Barium fluoride. Well, you could try to look up barium here, but barium's not listed. So we're going to have to look up fluoride. So see if you can find fluoride somewhere. That's right, fluoride is right here, and fluoride is listed as a soluble compound. but we should probably check to see if there's any exceptions. Ooh, and as you can see, barium is an exception. So the compound barium fluoride would not be soluble in water. So we would put the phase notation S, indicating that it's a solid and will not dissolve in water.